Okay, welcome back. So now in this example, we're going to talk about nautical miles. So traditionally, a nautical mile is defined as the distance or the arc length, the length of the arc of a great circle. Now, what is a great circle? So the great circle, if you look at the Earth, okay, so you look at a sphere and you look at the Earth. All right, so you look at a sphere. And a great circle is a circle. It's a circle that basically intersects well, how do I explain this? It's the circle that's created when you cut a sphere in half. So if you were to take a cross section of a sphere and you cut it in half right at the diameter of the sphere, where the diameter would be, okay? And so you look down at it, that's a great circle. So the great circle is the circle that's created when you intersect a plane through the center of a sphere. Okay, so you've got the great circle at the equator, right? So the equator represents the 0 latitude. So 0 degrees of latitude is at the equator, and then all parallel circles of latitude go in degrees all the way to 0 or 90. Is it, let me think. Yeah, so 0 degrees latitude is the equator, and then it goes up from there until you get to the pole. Each pole, okay? So now, so that's the idea of a great circle. Now, well, I guess, might as well explain a little bit more, since we're going to be talking about nautical miles. Okay, so a little bit of education here. So you've got latitude. Latitude are the lines that go across horizontal the sphere. So on the Earth, you've got the equator, which is 0 degrees latitude, and then you've got concentric circles or parallel lines from there that go up to the north and south poles. So the diameter of those circles decrease until you get to 0 at the poles. And then you've got the prime meridian. The prime meridian is basically the great circle that goes longitude. So this is the longitudinal line. So the prime meridian goes through and cuts the Earth into a left and right or east and west hemisphere. Okay, and then you've got parallel lines of longitude that go out where the diameter the diameter of those circles decrease to 0 as well. Okay, so now, nautical mile. So how do you define the nautical mile? Well, it's the amount of arc length along the great circle of the Earth, so in which we're talking about the equator. So the nautical mile is the distance, the arc length, the length of the arc of the equator that is what's the word? That is transversed when you go 1 minute. So the central angle of the Earth is 1 minute. So the arc length, right? So that arc length, when you have a central angle of 1 minute from the center of the Earth, that arc length on the surface of the Earth is defined as a nautical mile. Okay, so that's the traditional definition. Today, modern definition, it's just defined as 1,852 meters. Okay, the metric system. Okay, so 1,852 meters is what it's defined as today. Okay, so now, with that being said, all of that is this. If, based on modern definition, on the metric system, they define 1 nautical mile as 1,852 meters. So the question is what central angle is that based on? Well, no. That's not the question they want. No, they want to know what measurement of the Earth's radius. Okay, so they're still doing 1 minute, but what is the, we want to know what is the measurement of the Earth's radius is that based on? So we want to know the Earth's radius based on this definition of a nautical mile. Okay, so now, so we know the central angle is 1 minute, which is equal to 1/60th of a degree, right? So what do we do with that? Well, we want to convert this into radians. So that's going to be 1/60th of a degree times what? Pi over 180 degrees. Right? Now, if we take the formula for arc length, so, and we stick this in here, what do we get? We get, oh, we want to solve for r, right? Let's do that first. We want to solve for r. So r, in this case, so r equals s over theta. So now we're going to plug in. So r equals what? S is 1852 meters. Divided by theta, which is what? 1/60th of a degree times pi over 180 degrees. And of course, this is going to give us meters, right? So the degrees here cancel and we get radians, which is unitless. So our answer is going to be meters, which makes sense. And so now if we stick this in our calculator, we get approximately 6.367 times 10 to the 6th meters. Right? Now, and that's equal to what? Approximately 6.637, about 6,637,000 meters. Or we can just write this as 6,637 kilometers. Okay, so we could always change the prefix. Now, historically, the fact that the Earth is not a perfect sphere has led to many variations in the distance used for a nautical mile. Okay, so basically, in reality, the equator, the diameter of the equator is slightly larger than the diameter through the prime meridian, the distance between the poles. Okay? Okay. That's it. Have a great day.